All right, this next part of the lesson, we're going to do some examples for determining whether a relation is a function, and if it is a function, to decide if it's one-to-one, onto, bijective, or none of those, neither of those. And then we're also going to state the domain and range. So first thing, let's start with deciding if it's going to be a function. Now remember, if a relation is a function, the x value can't repeat. So if I'm looking at this list of numbers here, I'm looking to see if my x value repeats. So none of the x values repeat, so that means that this is a function. So since it is a function, next thing I'm going to decide if it's one-to-one, onto, bijective, or neither. Now when we first start these, it's going to be a lot easier to make those like diagram mappings that we saw in the examples. And then it will give us a better visual representation to decide if it's one-to-one, onto, or bijective. So let's do that. So when we do this, we want to list them in numerical order. So if I'm looking, looks like we go from 6, -1, -3, -5, -6. So I'm just going to make that bubble graph off to the side here. So 6, we have -1, -3, -5, and -6. And then my y values. So looks like we have 7 as the largest. So we did 7. I'm just going to put a dot there so I know that I used it. And then our next one looks like is going to be -1. So -1. And then we have -7, and we have 2 -9s. So I'm only going to write it once. All right, so now let's draw our mapping. So 6 maps down to -9. -1 maps to +7. -3 maps to -7. Let's see, -5 maps to -9, and -6 maps to -1. So as I'm looking at this, do we notice here how -9 is shared between two numbers in our domain? So that means that it can't be one-to-one. Now for onto, I'm looking to see if each of these have been used. So it looks like each one is used, so that would make this onto. Now, since it's not one-to-one, it's not going to be bijective. So the only one that this is onto. And then our last part is to state domain and range. Well, that's just listing our x values and our y values, and we've kind of already done that here. So now I'm just going to write it out. So capital D for domain, and then my curly bracket to show that these numbers are going to go together. And again, we always list them in numerical order. So you can either do descending or ascending. Typically it's from smallest to largest, so I'm going to do it starting with -6. So -6, -5, -3, -1, +6. So those are all the numbers in our domain. And then range is going to be the same idea. So these are it's just a list of our y values. So again, we want to start with the smallest number, so that's going to be -9, and then -7, -1, +7. Okay, so we have our domain and range listed. And again, you need to remember to include those little curly brackets because that tells us that this set of numbers belongs together. All right, let's try another example. So here we have a table that's listed. And again, to decide if it's a function, we are looking to see if our x values repeat or not. So as I'm looking down my list of x's here, I have +2, and then on the end I also have another +2. So that means that this is not a function. So if it's not a function, then it can't be one-to-one, onto, or bijective. So we're not going to write anything for that. But we can list the domain and range still. So again, domain is the x values, and we want to list them from smallest to largest. So we have -1, and that one also repeats. So, but I only have to list it once. Oop, and actually our smallest is -2, so let's switch that to be -2. And then -1, and we have +2. Okay. and our range. So again, those are our y values, starting with the smallest. So our smallest looks like is going to be -2, and then -1, 0, 1, and 2. So that would be our range. All right, next example. This is coming from a graph. So before we can really decide much, we need to write our coordinates down. So if we just start with this one is going to be at -1, 2, 3, 4. So -4, and then looks like -2. And then I'm going to put an A here to mark that I did it. So that's point A. Here's point B. So that one looks like is at -3, +1. And C is going to be our next one. So that is at 0, -1. And let's mark this one D. So that's at 1, 2. And our last one, E, is at 1, 2, 3, 1, 2, 3. So 3, 3. So again, to decide if it's a function, we just want to see if any of our x's repeat. So it doesn't look like any of them repeat, so that means that this will be a function. And then now we are deciding if it is one-to-one or onto. So let's go back to our little mapping thing that we did at the first problem. So again, if we start with our largest number for the x's, so 3, and then 1, 0, -3, -4. And then y is kind of the same thing. So if we start with our largest, so 3, 2, we have 1 here, -1, -2. So now we're just going to draw the correspondence. So -4 maps to -2, -3 maps to +1, 0 maps to -1, 1 maps to 2, and 3 maps to 3. All right, so if I'm looking down my list here, none of these share a correspondence in the x's. So that means that this function is going to be one-to-one. So I'm just going to write it as one-to-one. And it looks like every single letter in our range is accounted for, so that also makes this onto. And if it's both of these, then it is bijective. All right, next thing we are going to do is list our domain and range. I'm going to go down here, so domain, again, we're using our little brackets here. So smallest to largest number, so I'm just going to basically write it in the reverse order of this. So -4, -3, 0, 1, and 3. And then our ranges are y values, again from smallest to largest, so reverse order of that. So -2, -1, 1, 2, and 3.